Problem number 31 says we want to find the slope of a line, M, that passes through the origin. Now the origin is really just 0, 0, right? In fact, I'm just going to label this right now, x1, comma 1, of the tangent of, and they give us the function y equals the natural log of 2x. Okay, so let's graph this and take a look, see what it is. So if I graph this function, this is what I get. This is what it looks like. And they want us to figure out what the derivative of this is. Well, they worded it a little different. They want to know what the derivative of this is when x equals 0, right? Because this curve doesn't pass through the origin, but the tangent line does. So what they're really saying is, what is the slope of the tangent line to this function that passes through the point 0, 0? Okay? Now that can be confusing because we don't know what that point for x is, we don't know what the point y is, and stuff like that. So it doesn't necessarily mean that this line passes through the point 0, 0. We can see by looking at the graph that it doesn't. This is just like example number 3 from our textbook. So the way that we solve this is kind of complicated. So this is where we need to think. If I take the derivative of y, it's the natural log of 2x. Now that's not that hard to take the derivative of, because basically what I'm saying is that the slope of this line, slope of the tangent to the natural log of 2x, is the derivative of this function, which, think of this as like taking the derivative of the natural log of u. Well, we said that the derivative of the natural log of u is equal to 1 over u times du dx. Well, in this case, we're going to let u equal 2x, and then u prime, or du dx, is just 2. So when I take the derivative of this, I'm going to have 1 over u, which is 2x, and then we tack on the derivative of 2. Well, the 2's will cancel, and so my derivative of this thing is going to be m equals 1 over x, which is also dy dx. And I wrote it a little different, and I did that on purpose. But do I know what the x is? See, this thing has a tangent line that will cross through the origin. And it's somewhere over here, and I don't know what the x value is, I don't know what the y value is, and I can't plug it in. Does that make sense? So how do I solve that? Well, we're talking about the slope. So another thing I want to do is think about what the slope is. Well, one way that we can find the slope is I could say y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay? Well, 0, comma 0 is on this line. Now remember, this is the slope of the tangent line, not the original function. It's the slope of the tangent line of the original function, but we're talking about calculating the slope of a line that passes through the point 0, comma 0, because that's what it told us. Well, that would be minus 0 all over minus 0. How do I find the second y value? Yeah, I'm recording it. I think I'm recording it.
Isn't that y equals how?
Yeah. Yeah, we plug it into the original function, right? So it should be the natural log of 2 times some number. But I don't want to use x. God bless you. I don't want to use x. I want to use some arbitrary value. So I'm going to say 2a. Right? So I'm going to replace x with a. So this was like my, this is like my x sub 2 comma y sub 2, and we know to find that y sub 2, we're going to say the natural log of 2 times some number a. So what would my x value be? A, right? So I put A. Well, if I reduce all that, I get m is equal to the natural log of A minus 0. Well, minus 0, that kind of cancels out, right? So here's what I have. I have my slope of the tangent line is 1 over x. And then my slope of the tangent line is the natural log of 2a over a. You guys with me so far? Does that make sense? Couldn't I say they should equal the same thing? So I'm going to say 1 over x, but what is my arbitrary value that I'm going to plug in for x? A. Should equal the natural log of 2a all over a. Well, you're getting a little ahead of yourself. Let's clean this up a little bit. It's proportion, right? We have a bunch of numbers and then the variable a. So what would be the logical thing to do? Cross multiply and solve for a, right? But before I cross multiply, if I multiply this whole thing by a over 1, my a's cancel and I get 1 equals the natural log of 2a, right? Now here's what I want you to remember. I want to solve for a, and right now a is a part of a composite function. It's a function trapped within a function. So I've got to pull that 2a out of the natural log. How do I do that? Does anybody remember?
Do you change it to a log?
Yeah, you raise it to the e, and it is a log, right? So yeah, remember that the natural log of 2a is the same as log base e of 2a. Which, if I take this whole thing and I raise it to the e, they cancel because it's the same base. And so what I'm left with is just 2a. So if I say e to the 1 and e to the natural log of 2a, because the natural log is the logarithmic function of e, these cancel out. In other words, this cancels out, and I'm left with e equals 2a. Now, if we're going to solve for a, I get that a is equal to e over 2. Now, we've done a lot of math so far. The original question was m that passes through 0, 0 of the tangent of the function y equals the natural log of 2x. So I still have to solve for m, and I did a bunch of work, and the only thing I came up with is that a is equal to e over 2. How do I fix that? How do I make this information relevant? Because remember, what we're being asked to find is m. I'll give you a little clue. I have two. Well, sort of, yeah. So two of these equations, m equals either 1 over x.
So would 1 over x equal e over 2?
Sort of. You're in the right ballpark. So if this equals 1 over x, and we're going to arbitrarily plug in a for x, then we would say that m is equal to 1 over a. But what's a? E over 2. So this would be 1 over the fraction e over 2. That's like saying 1 divided by e over 2. What do we do when we multiply, or I said the answer. What do we do when we divide by a fraction? So we say 1 times 2 over e, which is equal to 2 over e, or 2 times e raised to the negative 1. Now we did a bunch of math. Who can tell me what that number represents?
A.
Slope of the tangent.
Slope of the tangent line that passes through the origin. So here we have a case where there's a straight line that passes through the origin. And this is the slope of it. Now, if I know the slope of an equation, which is 2 divided by e, right? And I multiply that times x, and then I tack on the y-intercept. What is the y-intercept of this tangent line? 0, 0. If I graph that, that line is going to go through the origin, and it is tangent to the natural log of 2x. But notice that it does not intersect at the origin. You guys see that? That's what we were trying to do.
There's no shortcut.
Oh, no. It'd be nice if there was. But that number just represents the tangent. The tangent line slope. Right? Good? Any questions from you guys? We are cooking with gas. That went better than I thought.